Hello and welcome to another exam paper walkthrough. Today we have a fantastic paper that I've very much been looking forward to doing. This is from a company called Maths Planner. I will mention them straight away. So this is, if you want to get in touch with their website, www.mathsplanner.com. Great paper. They produced a predicted paper based on Friday's paper 1. These are highly likely topics to come up. This is kind of our best guess. It's not a guarantee by any means. And they've produced this fantastic paper. It is a short paper designed to be done in an hour. So it's out of 65 marks. Topic list right on the front. So if you want that extra revision, those are the topic lists. And we will kick straight off. So question 1, we're looking at a standard form question. Write the number 0.00006273 in standard form. So we're going to put our decimal point in between the 6 and the 2. So our number is going to be 6.273. That's our number part, times by 10 to the, and I've moved my decimal point 1, 2, 3, 4, 5 places I've moved my decimal point to the right, so it's a negative. I haven't got a mark scheme for this, so I'm doing this from scratch. Hopefully I won't make too many mistakes. The second one, work out giving your answer in standard form. So I'm going to go to my calculator for this one, and I'm going to type it in exactly as it appears. So open bracket 1.6 times by 10 to the minus 5. And I want to close the bracket, times by, and then type the second one in, 4.8 times by 10 to the 3, close bracket, and for my denominator I want 2.4 times by 10 to the minus 7. And provided I've typed everything incorrectly, I'll just do a quick double check. It looks fine. I'm going to press equals. There we go. There's my mistake. There we go. So we get the number 320,000. And then we need to convert that into standard form for our final part. So 3.2 times by 10 to the, and I've moved it, in effect, the decimal point from there to there. So I've moved it 1, 2, 3, 4, 5 spaces. Right, question 2. So I'll get rid of my calculator for now. So Sheila truncates the number y to 2 decimal places. The result is 2.31. Write down the error interval. Well, truncating means something slightly different to rounding. It basically means whatever the digits are, we get rid of them. So the smallest that this could be is 2.31, and the largest it could be would be 2.32. If I'm truncating the number, slightly different to rounding, it just means that we ignore the digits after this point. We don't round, we trunk. And question 3. Jackie decides to cycle to her friend's house. She lives 18 miles away. Jackie estimates that her average cycling speed is 12 miles per hour. So I'll underline the key bits of information. How many minutes should it take her to cycle to her friend's house? So we're going to do our distance divided by our, so I probably should have put the formula in. So how long should it take? So if I start with my speed distance triangle, speed distance time, or the formula, speed is equal to distance divided by time. We want to work out the time, and it's asking for it in minutes, so we'll convert afterwards. So the time is going to be equal to the distance divided by the speed. So we're looking at 18 divided by 12, which is going to give me 1.5. And that's hours. We want our answer in minutes, so that's going to be 90 minutes. Okay, a sudden increase in wind reduces her average speed cycling by 20%. If she needs to be at her friend's house by 12:45 p.m. and leaves at 11 a.m., will she make it on time considering your wind speed effect? So if we're looking at this, in effect, if something's been reduced by 20%, then we've got a multiplier of 0.8. So we're now doing a similar formula. I'm still going to say that time is going to be equal to 18 divided by, and I'm going to do 12 times by 0.8 as my denominator. So if I go to my calculator then, so I'm going to do 18 divided by, let's do it as a fraction, the way that I've written it. So 18 over 12 times by 0.8, and that gives me a value of 1.875. So that's 1.875 hours. So let's just, so that's going to be 1 hour and 42 minutes. So that's going to be 1 hour and 52 minutes, sorry, 52 minutes and 30 seconds technically. So would she make it on time? So if she leaves at 11, so that's 11, so that's 11 o'clock plus my answer. Let's see whether that works. So she would get there at 12:52 and 30 seconds. So no, she would not. So she would arrive, so if I say plus 11 o'clock, she's going to get there at 12:52 and 30 seconds. So will she get there on time? No, she won't. Okay then, and question 4. Write 18a as a product of its prime factors. So in effect, all I'm wanting to do is times this by 18. So it's going to be a is going to be equal to, well, let's start and say 18 is going to be equal to 2 times 9, which is 2 times 3 times 3. So 18a is going to be equal to 2 to the power 4 times by 5 times by 3 squared times by 5 times by 7 cubed. So quite a long one. So 2 to the power 4 times by 3 to the power 2 times by 5 times by 7 cubed. 7 to the power 3. Find the highest common factor of 18a and b. In effect, we could look at this in terms of a Venn diagram. I'm going to take a slight shortcut though. So I know that this is b. So if I look at the powers of b, I've got a 2 in common. Powers of 2, I've got 3 squared in common. Powers of 5, I've got 5 in common. And then I've also got a 7 in common. So the highest common factor of that number, 35 times by 9. So let's just do it. 2 times by 3 squared times by 5 times by 7 gives us 630. Right, question 5. During a housing market crash, a price depreciates by 2% per quarter in the first year and 1.5% per quarter in the second year. Any house was valued at 465,000 at the start of the crash. How much is his house worth 18 months after the crash? So we're going to need 4 lots of the first one, and we're going to need 2 lots of the second one. And if we start, so I'm just going to do this as a single sum, 465,000 multiplied by, depreciates by 2% means a multiplier of 0.98 to the power 4, and I'm going to times that by 1.5% decrease means a multiplier of 0.8985. And I want that squared. So I'm going to type that into my calculator, and that will give me my value. So 465,000 times by 0.98 to the power 4 times by 0.985 to the power 2. So that gives me my value. I'm going to write all of that, and then I'll look at rounding afterwards. So 416,130. 0.6613. It's set to the nearest pound, so to the nearest pound, that's going to be 416,131. Okay, nice question. I haven't seen quarters. Good idea to look at that though. Right, question 6 looks like transformations. We'll get rid of the calculator for this one. Make it slightly bigger. Okay, rotate triangle T 270 degrees clockwise around the origin. So I'm going to change that to 90 degrees anti. So if I'm looking at about the origin, so about that point there, so this point is currently 1 across and 2 up, so it will go 1 up and 2 across. So that point alone will go to there, and then we can look for the orientation, and that's going to be our rotation. Label the new triangle A, so there we go, A. Translate the triangle A by a vector of 3, so that means 3 to the right, and minus 5, so that means down 5. So I'm going to pick a point. I actually changed my pen colour for this, just to show. So I'm going pick a point to start with, and I'm moving that point 3 across, and then 5 down. 2, 4, 5 down. So that point is going to move to there. So draw it from there, and that will become my second part. Label this one B. And I've just spotted I've actually made a mistake. Have I made a mistake? No, I think that's right. Just double checking it in my head. 1 across, 2 up, 1 up, 2 across. Okay. Okay. Question 7. Use your calculator to work out. So let's bring my calculator back in. So I'm going to type it in exactly as it appears. So fraction button. I want a square root for the whole of the numerator. And I want sine. Let's just double check my calculator is in degree mode. Um, 30 plus 2.01 to the power 4. And I'm dividing that by, open bracket, 6.7 minus 3.2. I don't really need the 0, and I want that to the power of half. And I'm spotting already, I've typed that in wrong. Let's just correct that. There we go. Sorry about that. 6.7 minus 3.2, and I want that to the power of a half. And again, I can type it in exactly as it appears. Could have typed it in as 0.5, but I'm going to go for exactly as it appears. Double check that I've typed that in right. So a lot of people prefer to do this in 2 steps. I tend to stick with 1 step, but then spend that little bit of extra time checking that I've typed it into my calculator correctly. And that gives me a value of 0.825. Let's just triple check that. And I've got, there we go. So I've got my half in the wrong place. The half should have been after the bracket, not before. So let's just clear that up. To the power of a half. Okay, and again, always worth that triple check. There we go. So I'm getting 2.1, so on. Write down all the figures on your calculator display. So I'm looking 2.192350859. Arrange your answer to part A corrected 2 significant figures. So let's just double check that I've typed it in right. This tends to be my biggest mistakes. Okay, round your answer to 2 significant figures. So this is the first significant figure. This would be the second. So we're looking at 2.2. Right. Question 8. The first 5 terms of an arithmetic sequence are 1.4 and, well, you don't mean, work out the value of the 69th term. Okay, so I'm going to find the nth term to help me find the 79th even. So the constant difference here is it's going down by minus 0.8, which means that my nth term let's just set that out slightly better, because I know I'm going to do a second line underneath it. So my nth term is going to be minus 0.8n, and then to get from minus 0.8 up to 1.4, I'm going to be adding on 2.2, so plus 2.2. So let's just double check that with the second term. So when n is 2, minus 0.8 times by, actually let's do the third term first. Negative one is a good one to practice or double check. 2.2, so the third term should be minus 0.2. So yeah, right, so the 79th term then, so the 79th term is going to be equal to minus 0.8 times by 79 plus 2.2. I'm just going to replay, and I'm going to change my value there to 79. Okay, so I get minus 61. Just double check what I've typed in there. Okay, part B, simplify. 2y to the 0 times by x squared. Okay, interesting. So that's going to simplify to 1. So it's going to be 2 times 1 times by 2x. So that's going to be 2x squared. For the third part, can be written in the form 2 to the power a. Show that a is equal to. Right, so I'm going to start by, I want all of these as powers of 2. So first of all, the cube root of 8 is going to be equal to, well, 8 is 2 cubed, so that's going to be 2 to the 3 over 2 times by x, and I want to divide that by, well, 64 is going to be 2 to the power 6, so 2 to the power 6 to the power 2y. Right, let's move that a little bit further. So I'm going to remove my brackets now, so I'm going to say that that's 2 to the power 3x over 2, or 3 over 2x, and I want to divide that by 2 to the power 12y. So if I combine these powers, then that's going to be equal to 2 to the power 3 over 2x minus 12y. So a must be equal to 2 to the power 3 over 2x minus 2y. And on to question 9. Given that P over Q is 3 over 7 and P over R is 4 over 9, find. Okay. So let's just start with P over Q first of all. If we rearrange that kind of, we would get, in effect, 7P is equal to 3Q. And if I do the other one as well at the moment, we've got 9Q would be equal to 4R, and that gives us some ratios that we can put in then in effect. So P to Q to R. I would need, so this would actually be the ratio of, and that should be a Q, not a G. My dyslexia hitting in a little bit there. I should be able to get my eraser on. There we go. So that's going to in effect mean that 7P is equal, 3 to 7 is the ratio P to Q, and then if we do the other one in a likewise manner, we've got 4 to 9. Then we need to combine the ratios with our middle part. So the lowest common multiple of 7 and 4 is going to be 28. So I've needed to times the first one by 4, so that would be 12, and then the second one would need to be times by 7, so that would be 63. So my ratio of P to Q to R is going to be 12 to 28 to 63. Okay, question 10. The arc length ABC has a length of 4 pi. AC is a chord. Work out the area of the shaded segment as a percentage of the sector OAC. OAC. Okay, so I'm going to start by saying that the chord length, or the arc length, sorry, so the arc is going to be equal to a quarter of a circle, a quarter times by pi times by r, sorry, I was going to go times by 2 pi r. So we're told that that's 4 pi. So 4 pi is going to be equal to a half of pi times r. So simplify. So the radius must be equal to 8 centimeters. Okay, then going to work out the area of the full sector. Segment. So the area, segment area is going to be equal to, again, a quarter of pi r squared. So that's going to be 64 over 4. I think it's going to be 16. Yeah, so we've got 16 pi for that. And then the area of the triangle, would be equal to a half of 8 times 8. So that's going to be 32. Right, and then we've got all that we need. So the area of the shaded section is going to be equal to this one take away this one. So the percentage shaded of the total is going to be equal to 16 pi minus 32 divided by the total area, which is 16 pi, and then I want to times that by 100. So let's type it in just like that. 16 shift pi minus 32 divided by 16 pi. We could have cancelled down by 4, but as it's a calculator paper, could have cancelled down by 16, sorry. So that would have been pi minus 2 over pi. That would still work. No advantage, though, on a calculator paper. So we're looking at 36.338022 ... show I haven't rounded, and then we're going to round to 2 decimal places, so that's going to be 36.34%. Okay, question 11. A bag contains only red counters, blue counters, green counters, and yellow counters. A counter is taken at random. The table shows the probability of taking a counter from the bag. The probability of taking a blue is 4 times greater than the probability of taking a green. So if I call that x, and I'm going to call that 4x. There are 50 yellow counters in the bag. Work out the number of blue counters in the bag. Okay, so yeah, we'll do it. So we'll work out the probabilities first of all. So currently 5x plus 0.35 is going to be equal to 1. So 5x is going to be equal to 0.65. So x is going to be equal to 0.13. So 0.13 there. And the probability of blue would be 4 times that. So we're looking at, is that 0.52? So 0.13 times by 4 would be 0.52. So we are told that there are 50 yellow counters. So 50 yellow counters. So I'm going to do it like this. I'm going to say that if there are 50 yellow counters, if I divide that by 0.2, that would tell me how many counters I've got, and then I want to times that by 0.52. So 50 divided by 0.2 and then times by the answer gives us 130. So that's 130 blue counters. Okay, Chloe takes a counter from the bag, notes its colour, then replaces it. She then selects the second counter, prime the probability that she picks 2 of the same colour. So in effect, that's going to be each one of these squared. Just trying to work out, often it's quicker to find the probability that she takes of different colours. It's not going to be in this case. So I'm going to want to do 0.15 times by 0.15 or squared plus 0.52 squared plus 0.13 squared plus 0.2 squared. So if we type that in like that, 0.15 squared plus 0.52 squared plus 0.13 squared plus 0.2 squared. So that should give me, as a decimal, 0.3498. Doesn't say anything about rounding. It's not a ridiculous answer to round, but we'll go for that. Question 12, here are some graphs. So we've got a linear, we've got a negative reciprocal, quadratic, another linear with negative gradient, cubic, looks like a sine curve, I forgot the name of it, but we'll, an exponential, another linear, and then we've got part of a square root, I think. Yeah, that would be a square root. If that is a square graph, that would be the graph of kind of y squared. Okay, which fits very nicely. So y is equal to the square root of x, that would be graph I. Negative cubic, that would be graph E. So positive intersect and positive gradient would be graph A. And then the sine one was graph F.